Hi, Maths with Kumar. Well, I want to ask you, have you practiced your practice 2? That's a challenge drill on coordinate geometry. Now you would have found that you're really sucked into the spice of coordinate geometry. And as the spice of coordinate geometry gets into you, you find your skills getting so much faster. Today we're going to do, alright, for the practice 2, see how many of them you're right. And you will be glad to see yourself moving up the slope of success in coordinate geometry, because there are many other topics to be focused on. So we move along and we master them. Alright, let's look at the first sum. Okay, the straight line y 2y minus 5 plus px is equal to 0. This line is parallel to this line. A line is always straight, right? So they say this line and this line are parallel. They want the value of p. You see, both of them have a y and an x, a relationship between y and x. What do we do to find the p? Alright? Well, we get the straight line in its real format. What should it be, a straight line equation? Y equals to mx plus c. Now if you look at this straight line, alright, it does not show us the c, it does not show us the gradient. So let's make it and express it in a better way. I hope the purple looks, is it alright on you or your eye? If it does not, I'll change my chalk. Now if you look at 2y, and you bring this px over minus px plus 5. Your y is going to be a minus p over 2 plus 5 over 2. So your gradient here, if you look at it, I forgot the x. Now if you look at the gradient of minus p over 2 will be the gradient. Alright, that's the gradient. Mx plus c. This will be your C. Now we look at the next equation. What is the next equation? Y over 3 plus x over 4 minus 1 is 0. Make y the leader of the equation. If you look at it, A, you move over. So when you move that, plus becomes a minus. Bring the minus 1 over, you've got that. Now you want to show that the two lines are parallel. If they are parallel, what must it be? The gradients must be the same direction. That's why they do not meet. So bring the 3 over. Every number, you multiply it by 3. That's how you get rid of the 3 below. So your y is, oops, I should not have written this line there. Y is equal to minus 3 over 4x plus 3. Do you see that? Now you look at this equation and said, hey, these two are supposed to be equal, right? They are parallel, and parallel means they have the same gradient. Equation question 1a, let me put that. So as the two lines are parallel, alright, as both lines are parallel. So what does it mean? You can tell you, when I say parallel, they say that these two have the same gradient. Okay, so minus p over 2 equals to minus 3 over 4. And both are minus. Remove the minus. Your p is going to be 3 over 4 times 2, which is 3 over 2. That's the answer. Did you get that? Good. Alright, so when you solve an equation, alright, we're not solving it as such. We are actually finding the gradient in this case. They ask you, they say that they are parallel, means the vital point is that they share the same gradient. So make it that way, A. Now the gradients are equal. Now look at the second part of the question, B. Now it looks very wordy, but sometimes it's good to interpret it in the easier way. Do not get disturbed by lengthy problem sums. Alright, they say the lines L1, L2 intersect at the origin. Oh la la, they meet at the origin. And what's the origin? The origin is actually 0, 0. Right? 0, 0. And the gradients of L1 and L2 are 5, 6 and 1/3. They are both positive gradient. But can you tell me which gradient is steeper? Which line is steeper? L1, because L1 has 5, 6, whereas L2 is 1/3, that is 2, 6. Right. And the points A and B lie on L1 and L2 respectively. These points lie in L1 and L2 respectively. Find the equations of OA, OB, and then it asks you to find the length of AB. Now we can translate this whole information into a little picture, as I said, a visual, a mental picture. What do you get from that? Did you get this? Hey, one line is L1, another line is L2. Alright, this is L2 and that's L1. And they say that they meet at the origin, which is 0, 0. And the point A, which is on L1 has, alright, A is 3K. And the gradient of L1 is 5, 6. Let me write this information down. 5, 6. And the gradient of L2, the gradient here, is 1/3. And the point B here is 6M. Got it. And now what do they want us to do? They want to get the equation of OA. Isn't it very easy? We know the gradient. What's the equation of a line? MX plus C. And what is the M here? 5, 6. So the equation of OA, what is it? Equation of OA. You know that Y is equal to 5, 6X. There's no C. It cuts at 0. Even if I put a 0, does it play a part? Not. Alright, you are moving along with me really well. Now what about the equation of OB? Isn't it the same story? Hey, equation of OB? Yep, equation of OB. Okay, the Y is equal to 1/3 X. There's no C intercept. Alright, now, having got this mental picture, do you see it is so visual? You can get the answer straight away. That's one of the important things I urge you to do. Next thing, they said, hey, what is the distance of PQ? But before we find AB, I'm so used to all these alphabets that sometimes I get them wrong. Forgive me. Right, now if you look at A, you need to find out what is K. And here you look at B, 6M. We need to find out what is M. So what is K? Let's find out. We said, alright, add 3K. That's at A. Alright, what happens? Your Y is 5, 6X. Your Y is K. Your X is 3. Put it in, duped up. Your K is 2.5. Yeah. Alright? So you got your A to B. Therefore your A is none other than 3 and 2.5. Excellent. Got it. Now, next part. Look at B. At B. What is B? At B, which is 6 and M. 6 and M. Now we know the equation. Alright, Y equals to 1/3 X. Your Y is an M. Your X is a 6. So your M is a 2. So therefore, once you've got that, your B, my dear, is equal to 6 and you get 2. That's your B. Now finding the length of AB. Now they want to find the length of AB. Is it a task? By now, I know you know it because you must be finding Pythagoras theorem pretty easy. And we also apply our common sense thing, remember? We know the length, the formula for the length of a line. What is the length of AB? You know, you could put this formula, y1 minus y2 squared plus x1 minus x2 squared. You know what is this point? This is 3 and we found out is 2.5. x1, y1, this is 6 and 2. If you take 2.5 minus 2 and you square it, alright? And then plus your x, 3 minus 6, and you square it. You get a half, and a half squared will be half times half is 1/4, right? And that will, you get that there. And this will be a minus 3. A minus 3 and a minus 3 will give us a 9. So you get a 9/4. 9/4, 9 and 1/4, sorry. That's what you should say, not 9/4. 9/4 is 9/4, alright? 9 and 1/4 minus 3 squared. Look at that. And that will mean you have a 36 plus a 1, a 37/4. You can find the square root of 4, and that's the length of AB. Now this is, I said to you, the nerd style by formula. But you can also do without the formula, right? Let's look at it. How do we do it? We look at this and we say, hey, this 2.5, sorry, this is 3 and that's 6. So the distance between it is 3 units. This is M. Your M here is 2 and your M here, oops, your M here is 2.5. The distance here is half. So you find the square of it. 9 plus 1/4 is 9 and 1/4. That's the square root of it, the length of AB. Alright, which gives us 36 plus 1, 37 square root over 2. Alright, now if you get it, very good. And I'm confident you must have got it. Smile.